Hello everyone. My name is Sumedh, and I am going to present before you for the topic color image processing using Fourier transform. Basically, we will understand the topic one by one. We will first get to know about what is Fourier transform. So, we all know that the Fourier transform is responsible for converting a time or space domain signal into frequency domain. We get a lot of power basically to play with the image, okay, by converting it in frequency domain. So we know that there are two types of signals. One is continuous signals, and the another one is discrete signals. This is the equation of for the continuous signal. We can directly convert it into the frequency domain. And similarly, we have the equation for discrete signal. We just have the summation sign over here. Okay. What is image processing? When we get to image processing, we know that the Fourier transform plays with the intensity of the signal, not with the color. But the thing is, every single image is made from three colors: red, green, and blue. We will see how that works. Color image processing using Fourier transform is an advanced technique used to analyze and manipulate color images in the frequency domain. We can perform six operations. Those are noise reduction, image filtering, image compression, image reconstruction, pattern recognition, and sharpening or blurring of the image. We'll see through codes how this takes place. But before that, we have to understand how a camera works. So basically, this is a camera, and you must have heard about like camera having something written over it as 48 megapixel, 108 megapixel. So this image is taken from a Samsung gallery. Basically, how a pixel works is every pixel has four sensors: two of green, one red, and one blue. Okay, so they are responsible for detecting the color present in the surrounding. Okay, there are two channels for green, one channel for blue, and one channel for red. We have to keep that in mind, so as while reconstructing the image, the ratio is taken perfectly fine. Okay, so this is how a pixel works. We'll get to the codes, how it works. Let's see that. Okay, so okay. I'll be basically performing all the operations on three images. The first is of Trifid Nebula. This image is taken by me. The second is of Whirlpool Galaxy, and the third is of course, myself. Okay, so let's get to the codes. I have divided the codes in three parts. So in the first part, we will just try to apply the Fourier transform uh, and divide the original image in three channels, namely R, G, and B. Okay, so let's see how that works. So here we have used OpenCV. It's a great tool. It has a lot of inbuilt defined functions which are really useful while we are dealing with an image. Okay, so this is OpenCV. So here we divided the channels into R, G, and B. Okay, we have defined Fourier transform. Then we apply the Fourier transform on all the channels individually. Then we are applying get magnitude spectrum. So we are getting magnitude spectrum through it. Okay, and we'll just plot them. Okay, so here we have got three results for it: the red channel, the green channel, and the blue channel. We have also performed this in the class, so all of us know that this is how a frequency domain function frequency domain image looks like. Okay, so these are the three channels. We'll combine them in future. Okay, in the next part we'll see, we will what we'll do is we will like divide the image in RGB channels, then apply the Fourier transform, then apply the inverse Fourier transform, and then recombine them. Okay, so here we have defined the Fourier transform, the inverse Fourier transform. Here I have imported the image, and we have just applied this process individually on all the channels, and this is the reconstructed image. So I have told about image reconstruction. So this is it what looks like. Okay, so this was the original image, and this is the reconstructed image. Now there is not much difference in the two images we are getting, as we haven't applied any process or any type of filtering inside the inside the code. Okay, so I'll just show in in between the Fourier transform and the inverse Fourier transform, we can apply a lot of processes such as filtering, high pass filter, low pass filter, and many more to get an different or modified image. Okay, so let's get to the third code. In this code, we will be applying high pass filter and low pass filters. Okay. So again, I have defined the Fourier transform, inverse Fourier transform, low pass filter, and high pass filter. Okay. So let's see what it does. Okay. So let's see. Okay. We have again the same code. So this was the original image of the Trifid Nebula. We have performed Fourier transform on it. Then we have applied the high pass filter, low pass filters, and again we performed the inverse Fourier transform to get the final image back. Okay, so I don't know if you are much able to see this, but you can see that we are getting a blurred image in low pass filter. This is because the higher frequencies are obstructed in low pass filters. Therefore we get a blurred image, and whereas in high pass filters the lower frequencies are obstructed, therefore we get a sharper image. So you can see the Trifid nebula is completely gone, and we can see all the other stars up here. Okay, so let's see the plots for this. I also did the process for the Whirlpool Nebula. So this is what the image looks like. This was the original image. This was the image we applied after low pass filters. This is really useful while post processing astronomical objects or deep sky objects. Okay, this is the high pass filter. You can see the stars over here. Other than that, the Whirlpool Nebula is gone here. Okay, and this is for the Trifid Nebula. This was the original image. This was after applying the low pass filter, and the last one by applying the high pass filters, we can just see the stars. This is really useful while processing of images. Okay, it gives a lot of power to play with the intensities, play with what type of data you are getting, and many more like that. But there is one more thing remaining in this. Uh, we haven't talked about is there is one more thing remaining, which are the challenges we face while using Fourier transform for image processing. Okay, so the complexity of the mathematical operations we perform while doing so are very high. For example, the last code we run took me 1.5 minutes to run the code completely, and which only applies the high pass and low pass filters. When we are doing much more complex operations, it will take much more time. Okay, so complexity is a great issue. Second up we have is color channel artifacts. So processing each color separately might introduce artifacts if not done correctly. Okay, so basically color distortions may happen in the final image. Okay, third is aliasing. When modifying frequencies, improper filtering might introduce aliasing effects, where high frequencies distort low frequency components. So basically, higher frequency components overpower the lower frequency components. Okay, so thank you so much. That was it. Hope you liked it. Thank you.